This is the second part of the first lecture of week 12, where we'll discuss one example of text problem where we can obtain linear system of differential equations. The name of this problem is interconnected fluid tanks, and this problem is discussed in section 5.1 of the book. Let me explain what the problem is about. So assume that now we have two tanks, so tank A here and tank B here. And these tanks are connected by pipes. So you see we have some pipes. And we have that some water flows into tank A through this pipe here and flowing out with the same rate from this tank B. And also we have some water flowing around from A to B and from B to A. And what we are given? We're given that the volumes of this tank, of tank A and B, are 28 liters. And we also have some initial amount of salt in each tank. So here we have x0. Let's say, just for simplicity, we take this 1 kilogram, and at tank B we had initially 2 kilograms of salt. And by x of t and y of t, we denote the amount of salt at a time t in tanks A and B, respectively. And what do we need to know? We need to find the kilogram of salt at a time t in each tank. So to find x of t and y of t functions. And we will use the same law that we used just for one tank, so that the rate of salt is the input minus the output. The input rate minus the output rate. And we will write the same law for two tanks now, for tank A and for tank B. Let's do this. So let's first discuss tank A. We have amount of salt at the time t is x, and the rate will be the rate of input. Let's see what the input in the tank A is. The input is through this pipe here and through this one. So let's now talk about this one. It's given in fact that the fresh water flows into tank A, so there is no salt in this water. So we get 0 because there is no salt here. And the second inflow is from tank B here. And what is amount of salt at the time t in B? This is y. In fact, the concentration is y over 24 liters, right? And to find the amount of salt at the time t, we need to multiply it by the velocity, 2 liters per minute. So you see, if we write this is kilogram per liter and multiply by the velocity 2 liters per minute, we get kilogram per minute, right? So these liters will be cancelled. And in fact, we indeed need kilograms because x in kilograms per time in minutes. So the input rate now is y over 24 over 2 kilograms per minute. And what is the output rate? The output we obtain through this pipe here. And again, the concentration of the flow out, x over 24, and times the velocity, 8 liters per minute, we have x over 24 times 8 liters per minute, so this amount. So this is everything about tank A. What about tank B now? Okay, in tank B we have only one input through this pipe. And we know that through this pipe we obtain x over 24 times 8 kilogram per minute. Sorry, we have to first write the dy dt. The rate of change of salt in tank B is dy dt. And the input is x over 24 times 8 through this pipe here. And the output is this one and this one. So the output is the concentration y over 24, and since the output is the same concentration of salt will be flowing out of these two pipes, and the common velocity is 6 plus 2, which is 8. So we obtain this rate of output. So overall, let's write the system that we get. So this x prime is y, and if we cancel this 24 and 2, this is y over 12 minus x over 3, and y prime is x over 3 minus y over 3. So we get this system, and also we know the initial values. X of 0 we assume this is 1, y of 0 we assume that this is 2. So you see that in this example we obtain indeed linear system of differential equations. So now let's solve this system. So let's apply the Laplace transform, for example, method. So taking the Laplace transform, we obtain x minus 1 is 1 minus 1 over 3x plus 1 over 12y, and sy minus 2, so this 1 and 2 are the initial values here, right? This is 1 over 3x minus 1 over 3y. So we get such system for Laplace transform. So let's rewrite it to make it more beautiful. So we contain everything which is unknown on the left. So the coefficient of x here is plus 1 over 3. And the coefficient of y is minus 1 over 12. And let's move this one to the right. And here the coefficient of x is 1 over 3, minus 1 over 3. The coefficient of y is s plus 1 over 3y, right? Because we move this one to the left. And this minus 2 when we move to the right will be 2. So we get this system. Okay, let's now do something to eliminate one function. For example, we can find x from the second equation, from this second equation. This is s plus 1 over 3y minus 2, so we write minus 2 here, and 1 over 3x we move to the left and multiply by 3 everything, we get this thing. So if we now open the brackets, we obtain 3s plus 1y minus 6. So this is the expression for the function x. Now we substitute this into the first equation here. So we obtain x times this thing. So s plus 1 over 3 times 3s plus 1y minus 6, s plus 1 over 3 minus 1 over 12y is 1. Let's again move the unknown y, we leave it on the left side and move everything else on the right. So what do we obtain here? This is, in fact, this is 3s plus 1 over 3 squared, right? Minus 1 over 12y. And on this side we have 1 plus 6 times this one plus 6s, and when we add this one we get 2. So this is in fact 6s plus 3. And if we open the brackets here, in fact the easiest way to do here is to maybe write this as follows: 3 we take out of the brackets, we obtain s plus 1 over 3 squared minus 1 over 36y. And 3 from this to s plus 1. So now you see this 3 can be cancelled. And this thing in brackets, this is different of squares. So what do we get here? S plus 1 over 3 minus 1 over 6. S plus 1 over 3 plus 1 over 6 y. This is 2s plus 1. So 1 over 3 minus 1 over 6. This is 2 over 6 minus 1 over 6. We get just 1 over 6, right? So s plus 1 over 6. And this one, 1 over 3 plus 1 over 6. We get 2 over 6 plus 1 over 6, which is 3 over 6, which is s plus 1 over 2 y. This is 2s plus 1. So we obtain that y is 2s plus 1 over s plus 1 over 6, s plus 1 over 2. In fact, we can simplify this even more if you write 2 times s plus 1 over 2 here, s plus 1 over 6, s plus 1 over 2. You can cancel this 2, we obtain 2 over s plus 1 over 6. So y of t, this is inverse Laplace transform of y, of capital Y at a point t. So this is inverse Laplace transform of 2 over s plus 1 over 6. And using now the table of Laplace transform, we obtain that this is 2 e to the minus 1 over 6t. And let's find x of t. So x of t, for example, can be found from the second equation here. So we know that y prime is 1 over 3x minus 1 over 3y, right? 1 over 3x minus 1 over 3y, yes. And from this one we can find x is 3 times y prime plus 1 over 3y, or this is 3y primes plus y, right? So x is 3 times y prime is 2 times minus 1 over 6 e to the minus 1 over 6t, and plus y, which is 2 e to the minus 1 over 6t. So what do we get overall? This is 6 minus 1 over 6, so just 1, plus 2, just 1 e to the minus 1 over 6t. This is answer for x, and this is answer for y. So the problem is solved.